Hi there. Today we're going to be having a look at the July sample test. This should give a bit of an indication of what you can expect in your July term test. If you have a look at the questions, you'll find that you are given two tables. There's an animals table and a samples table. And at the bottom of the question sheet, you'll find the data files. Please download those and extract those in your projects folder. I have done so here. What you're given is the project file, DNA archive, then there is the main form and a data module, UDM. While we wait for that to load, the animals table has three fields: an AID for the animal ID, common name and scientific name, CN and SN respectively. And the samples table has a sample ID, SID, an animal ID, animal. This field and that field have the same values. They've got that primary key, foreign key relationship which you may end up having to use in the question paper. We have a gender field and a date field for the date of a sample. The scenario you're looking at is you're assisting a local zoological group who form part of an international DNA archival facility. The archive would potentially enable one to identify diseases, track genetic changes, and even restore entire species if one of the archived species became extinct. So that data is stored in very simplified form in these two tables. Right, let's have a look at the Delphi. We have the two forms, form main and UDM. The data module gives you the connection. This will be established for you. A table animals ADO table, which is connected to the animals table. Table samples, another ADO table, which is connected in this case to the samples table, and the data source controls, which will be used to connect to the DB grid. There's also an ADO query. The ADO query has absolutely no minimal SQL provided at all. There's another data source which will be used to connect the query to the DB grid on the form over here. Right, there's the DB grid which will be used for some of the data. So that we can keep track, I'm going to be opening the question paper on the sidebar on the right here. All right, let's have a look at the first question. The CEO of the Cape Town Centre would like to know how many samples of Impala, the animal ID equals 5, there are in the database. So we're going to use a control. The first section has to be done using Delphi's database controls, and the simple way of doing this one is to use a filter. So let's have a look at that. You can ignore the stuff that happens up here. This is provided for you, and that exists solely to connect the DB grid for your display. Right, everything is on the data module, so I'm going to have to reference the data module when I'm talking about the different tables. DBL samples, okay, that's the ADO component we're going to be working with. Set the filter to false. And now we're going to set our filter. A filter for an ADO table takes the place of the where clause in an SQL statement. So if I had a statement which did something along these lines: select everything from, this is the table of samples, where, and if we have a look, looking at the sidebar on the right, the samples table has animal ID with the name animal, not AID as given in the question. So I'm going to have to use animal equals 5. The filter would contain this portion, the where portion. and we can make dm.table samples we can make filtered true. We don't need that. If we run our program and I click compiler, that should give me all of those. No join was required to link this to the animals table for the name. We just wanted to know how many of that ID there were. Right, having a look at the second question. A user enters the details for a new sample in the fields at the top of the form. Those are the fields provided over here, AID, gender, and the date. Complete the code that enables a user to add this to the samples table by pressing add. So we are going to be working here. Whenever you insert a new row into a database table, you'll be using the insert command .tblsamples.insert. This adds a new row and places it in edit mode so that we can now update the values. dm.tblsamples, and the first sample is animals, not AID as it says on the label above the button. That stands for animal ID, and that will be from this edit box. The first edit box, if you have a look on the left, you'll see is named edit 3. So we'll be using that one, edit3.txt. Then dm.tblsamples, and we're taking from the second one, we're looking at gender, and this is going to be edit 4. So gender the last one, dm.tblsamples date, comes from this control, a date time picker. A date time picker gives you a drop down box that allows you to choose a date, and depending on the format that it's returning, we either use the date property. You'll see here we have the date property. If its kind was time, then we would use the time property. And if we wanted both, then it also has a date time property that we can refer to. But in this instance, we're using date, so we'll be using the date property. And its name, you'll notice here on the left, is date time picker 2. So date time picker 2.date. The last step is we have to commit our changes to the database. As things stand, no values have actually been sent. This is sitting in memory in Delphi. dm.tblsamples.post. And as soon as we have posted the changes, those changes are permanent in the database table, and anyone else can then access them. Right, let's have a look at the next question. During sample testing, a researcher discovered that sample 61 was registered with the wrong gender. Enable a user to correct entries. You have to do two things. First, search for an SID that is entered into an input box. Do not use a filter. If an entry is found, the fields in the edit boxes at the top of the form should be populated with the data from the samples table. This is generic. The sample 61 is just an example from the scenario to explain what's going on. We have to be able to do this for any sample. The first thing we're going to have to be able to do is input a value. Let's create a string variable that we're going to use to get input from an input box. sinput equals And there are the three parameters. The first one is the caption. Leave the default value blank. Just to be able to see this better, I'm going to hide those two. And now we can go about trying to find this particular ID. We're going to use a common search routine. This is how we would apply that to a database table. Start by going to the first row of the table, dm.tblsamples.first. Then the regular search routine we'd always use. I'm looking to see whether dm.table.samples SID matches what was in S input. If it's different, I'm going to keep on going to the next row, dm.tblsamples. Next. And of course, remember that the sample may not exist. I'm also going to have to be able to handle the case where the sample doesn't exist and we run out of items in the database. So there and not tblsamples.eof. Right, I now have two possibilities. I either found the sample or I reached the end of the database table and had not found the sample. It's complaining about spelling. And this is in the data module. Okay. We check that with an if statement. Can copy this. We aren't asked to do anything specific when we don't find anything, but show message. This is where I would do that anyway. SID not found. I prefer to do things this way around. Keep the results in the while and the if using the same condition, and handle the case of I didn't find the message first. That way everything that carries on below this particular statement assumes that we did find the ID. Okay, if we did find the ID, we now have to set the values in the edit boxes. So the first one was edit3.text, and that is going to be dm.tblsamples and animal. Edit4 dm.tblsamples.gender, and remember the last one was that date time picker, date time picker 2. So date time picker 2, and we're setting the date property, date colon equals dm.tblsamples date. Remember using the square brackets and inverted commas to refer to the values in the particular fields. Using this way of doing things, Delphi automatically handles the conversion for the different types. So even though the database provides a date as a string format, Delphi does the conversion automatically and stores it in the date format used in the date time picker. And there we are. We'll get on to the next question in a moment, but just to illustrate the way this would work, I can now search for ID number 5, and you'll see it's moved things immediately down to row number 5 over here. Any modification would be done to that particular row in the table, and you can see we have those items showing in the date time picker and the relative edit boxes. So, on to the second part of question 3. When the update button is pressed, save the corrected details to the samples table. We're going to the update button. Always remember here that databases are multi-user. This means that someone else can be accessing the values while you are working on them. When we're going to update a value, we've got to change data that is live on the database and potentially being accessed by someone else. To be able to do that, we have to signal to the database that we are about to edit this field. We've got to provide fair warning. So TBL samples, and that is of course on the data module, .edit. This puts the database table in edit mode, and that particular row is flagged for editing. Only that row. dm.tbl samples. First one was animal. Colon equals, and any changes in edit 3 are then applied to that particular field. dm.tbl samples gender edit 4.text, and last one dm.tbl samples date, and this is going to take the value from our date time picker to date. And just as with the insert, I'm going to have to commit those changes There we are. Changes made permanent. Okay, save your work regularly. You lose a lot if Delphi crashes. Right. The next questions are the SQL questions. Create a query to list all the animals in the database, i.e. list all the animals in the animals table. So we're going to the list button, and this will be an SQL query. We're going to be typing an SQL statement that looks something along these lines. Select everything from animals. Not TBL animals. Remember, we are now referring to the animals table in the database, not the ADO table on the data module. You weren't asked to order this at all. I could have said order by common name or some such, but nothing like that was asked in this particular question. You weren't asked to filter this in any way, so there's no where clause. This one is really simple. Right, we're now going to refer to the query. So there we are, query arc dot active. Always make it non-active first. We don't want to have any false results that come from partially edited SQL. dm.queryArc.text .sql.text. That's the SQL property we're now editing now. And I'm going to be using 2 lines. The first line and the second line. And when we're done, we can make this active again. dm.queryArc.active. Running the program. List, and there are our animals. Moving on to the second question. To check for species bias, the overseer of the project wants to see a list that shows the number of samples for each type of animal. Right, as soon as we say number of samples, we're going to be having to look at the samples table again. Ordered from most samples to least samples. Only show the animal ID and the number of the samples. If we look at the table, we'll see that animal ID is just the ID, sample ID. We don't need to show the animal name. Showing the animal name would require a table join. So there's no table join for this question. Right. Our SQL for this one then is going to look something like this. Select, and we're going to want animal. Remember, that is the animal ID. And we're going to want a count. We need to count how many of each animal there are. So count animal as samples. We aren't told what the name should be, so I'm just going to use samples from animals. And because we are using an aggregate function, I'm going to have to use group by. Group by animal. That is the one field that is not part of the aggregate function. And we need to order this. We want to order this according to the number of samples. Order by. Now here is the problem. I want to order by this formula. I can't refer to the name that I have given this yet. I can only refer to that once this SQL query has already executed. That's the only time that is actually populated with values. So I'm going to have to repeat the formula. Count animal. There will be my SQL. So let's input that now. dm.query.active equals false. dm.query.sql.text. I'm going to have 4 lines of SQL, so let me just make some space for that. And I can drag this SQL into place. I'm not going to be getting the animal names. That would require a join. There we go. And the last step is let's make this active again. So count samples. Parameter animal has no default value. That means I have a spelling mistake somewhere in this. Let's stop that quickly. And that comes in because I said that I was going to use the samples table. That means this is from samples. And that probably means I can't use the word samples as my column. So let's call this sample count. And that is count samples. There we go. And you'll see ordered at the moment in ascending order. We want from most samples to least. So I've left out one important word, DESC, which says do this in descending order. Count samples. There we go. From the one with 18 samples on down to the few with just 3. Okay, question 2.3. Each sample has to be properly labeled to prevent mix-ups. The label should contain the following information: sample ID, animal name, scientific name, gender, and sample date. We're going to use an input box to get the sample ID and use this to determine the information that will be printed on the label of the sample. This can be displayed in the DB grid Now, as soon as we have something like this, which is going to require information from both tables, sample ID is in the samples table, animal name and scientific name are both in the animals table, gender and sample date are both in the samples table. As soon as we have something like this, we're looking at an inner join. So our SQL is going to look a little like this. We're going to want to select the sample ID from the samples table. We're going to want the common name of the animal, the scientific name of the animal, the gender, and the date, the sample date. And we're going to take this from table samples, in join, table animals, on samples.animal equals animals.aid. And we're going to be doing this for a particular sample ID that is input in an input box. So where SID equals the value we're going to get from S input, a variable which I must still create. S input is a string, and this value is going to be from an input box. Enter SID. There we go. Right. Let's add this to Delphi. We're going to be doing this exact same job. So I'm just going to cheat by copying that code. Plus, and we've again got 4 lines of SQL. So let me give myself space for 4 lines. And then we're going to set this true to execute this. Select from, on, and where. SQL statement should end with a semicolon. There we go. This should end up being displayed in the DB grid. We want to generate the label, and let's do it for that Impala again. Sample parameter S input has no default value. Break. Remember, I've now put this value in literally, so it thinks that this is an SQL parameter, which means I need to tell it that it is not an SQL parameter, but rather that we are busy adding the value that's inside that variable to the string that makes up the SQL statement. Remember, if this value was supposed to be interpreted as a string in SQL by Microsoft Access, I would then have to put it in a quoted string, but because this is a number, a numeric value, I don't have to do that. Right. And generate label. Let's do that, and there we go. Number 5, SID 5 was a wallaby, and we didn't set the column widths, but you'll see it's got the gender and the date and the scientific name and everything else that we need to display. Right, last question. We need to write all of this to a file. The sample labels need to be saved in a text file so that these can be sent to the label printer. Use the data from the previous question to generate a formatted label and save this in the text file label.txt. The label should appear as follows. Bear in mind the note at the bottom. This will apply to all your questions particularly if one question in some sense depends on a previous answer, you must still do this question even if the query it is based on does not work. Even if you can't get the database queries they depend on to work, you can still get the marks for writing information to the text file. Right. When we are working with text files, we need a file variable, which I'll call con for connector. We are creating this file, so we don't have to check whether the file already exists. We can start with assign file, con, and then the name of the file. In this case, we are given a file, label.txt, label.txt. And we are going to use rewrite because we are going to write this data to the file. I'm going to write several lines. The first line is going to be sample ID, and that will be the sample ID from the database row. Now remember, when you've executed the select statement, the row pointer in the table or the query that results from your select statement points to the row of data that you are working with. In this case, I've generated an SQL statement in the code above, which is going to choose a particular animal, just one. So there will be one row in the resulting query. This will automatically refer to the data that I'm working with. So I can reference that directly. Query arc.sid. And that refers to the SID field from the query. Not from the table in this instance, but from the query. And the next one, the same idea, is common name. And we're going to add to that dm.query and now cn. And this refers to the cn field in the query, the new table that results from the executing my SQL query. Next statement, write line. And we're now looking for the scientific name. dm.query sn. All of these, remember, are being sent to the file that is linked using that con variable. Without this, it would be sent to console output. Con. Next is gender. And the last line is the date. And when you're finished, always remember you need to close your files. It's one of those, it's just polite. Right, let's see what this does. We generate a label. Let's get that wallaby again. There we go. Save label. Could not convert variant of type Unicode string to type double. This means that in this instance, these are not automatically being converted to strings. Delphi doesn't know at the point that it refers to these that I'm going to be using them as strings. So this particular value, the SID, remember, is a number. I'm going to have to do an int to str. And the other one that's returned as a numeric value is the date. We're going to have to do date to string for that one. We can now try this again. Stop and run. We're going to generate our wallaby and we're going to save the label. Nothing visible happened. Let's see if we have the label in our data folder. Yes, we do. And there it is, sample ID 5. It's a wallaby and it was on that date. And there we are. I hope you won't find that too difficult. See you next time. Bye for now.